Alright, so I'm gonna be talking about a very important article from IBM, which is this one in 2021, Leveraging Abstract Meaning Representation, AMR, for knowledge-based question answering. And this article is really similar to the article in 2021, so I don't repeat it. And you see that the problem of existing algorithms is that existing approaches face significant challenges, including complex question understanding, necessity for reasoning, and lack of large end-to-end training datasets. So what is the idea of this paper? They propose neurosymbolic question answering, a modular knowledge-based question answering system that leverages first AMR parsers for task-independent question understanding. So it's a system of systems, as they pointed in another article from IBM again. It's a system of systems. It has AMR block, it has logical modules, and also it's a simple yet effective graph transformation to convert AMR parsers into candidate logical queries. Because if you want to retrieve something from knowledge base, then you need to convert. Your AMR does not help anymore, but they are good features, so you can just convert it to some logical forms, like for example, in SQL databases, you can convert it to some SQL queries, and that would be enough for that table to understand. Or here, when we work with knowledge base, we need to work with SparkQL languages like that, or it depends on your database. So we need to convert our AMR to some logical queries. And a pipeline-based approach which integrates multiple reusable modules that are trained to specifically for their individual tasks, such as semantic parser, entity and relationship linkers, and neurosymbolic reasoner, and do not require end-to-end training data. So this is the architecture. We know how to create AMR parse. I've explained it in a playlist for semantic parser, lecture 20. So if you look at my video on lecture 20 of semantic parsing playlist, you can understand. Then you give it to entity linking and path-based graph transformation, because we need relation linking in order to understand a knowledge graph logic. And then they give it to the reasoner, which could be a logical neural networks. So after you have AMR, you create the query graph. I will explain this, and then you can either create a SparkQL or even directly to Lambda calculus. It depends on what you are doing, what kind of systems you have in your company or university, but you can give it to a SparkQL as well. So you know that we are parsing it. These are the relations, for example, arg0, arg1, then it becomes arg1 and then modifier, and then so you see you can parse it. And here you relate it to, because you need to relate it to knowledge graph, so that's another process. So what is the query graph? Query graph Q is a directed edge labeled graph which has a similar structure to the underlying knowledge graph. Our goal is to transform the AMR graph into the corresponding query graph. However, such transformation faces the following challenges. N-ary argument mismatch. You know that query graph represents information using binary relations. whereas AMR graph uses prop bank frame sets that are n-ary. So how do you match them? So there is a mismatch, a natural mismatch. For example, node produce 0, 1 has 4 possible arguments, whereas its corresponding knowledge graph relation is a binary relation. So we transform the AMR into query graph. The vertex set of query graph represent entities. On the other hand, AMR graph contains nodes that are concepts or prop bank predicates, which can correspond to both entities and relationship. For example, in figure 1 that I showed you, produce 0, 1 and star 0, 1 and Spain are nodes in your AMR graph. So the AMR has to be transformed such that the nodes primarily correspond to entities and edges correspond to relationship. So this is the algorithm that is shown here. We need shortest path after we got the AMR, because we need to convert it to some triples. And this is an example. We are converting it to some triples, and this is the query graph, for example, because we convert it to query graph, and there is sometimes a mismatch